Hi everybody, we're going to start 6-1 today involving zero and negative exponents. And then you're going to have an assignment that's in Canvas. All right, so let's go through these real quick. You're going to want a calculator available to you. So whether you use Desmos on a different tab or a handheld, that is completely up to you. So 5 to the second power would be 5 times 5, which equals 25. And 10 to the third is 10 times 10 times 10, which is 1,000, a 1 with 3 zeros. 4 to the fourth power means 4 times 4 times 4 times 4, which is 256. And 8 to the third power, 8 times 8, that's 64 times 8. I don't know what that is. Let's see. 512. And you're welcome to use a calculator here. That's totally fine, as long as you understand exponents are repeated multiplication. All right, so I want you to notice the difference here. I want you to notice that the -7 is inside the parentheses, and so is the -10 inside. And then on the 4 to the fourth, it's on the outside. So these are very different kind of problems. Okay, this one just means -7 times -7, which is 49. And if you're putting it into the calculator, you must put the parentheses. Over here, this one means -1 because there's a 1 outside the parenthesis, and then it means you're multiplying 4 times. So we just saw on the last screen that 4 to the fourth was 256, and then times -1 would be -256. And again, if you are typing it into a calculator, you must type it exactly like it's written. You have to use the parentheses. So this one, because the negative is on the inside, means -10 times -10 times -10 times -10 times -10. So that's a 1 with 5 zeros. And then it's got 5 negatives. An odd number of negatives makes it negative. So this is -100,000 as my answer. This one, again, means -1 times 6 times 6. This is -36. I'm wanting you to understand the difference here, and I'm wanting you to see if you put the parentheses in when you type, it makes a very big difference. Okay, the difference would be that negative. All right, the first rule, any non-zero value to the 0 power is 1. So most of these are to the 1 power, and you could check it by putting it into your calculator on the numbers. Not so much with the letters, but just knowing the variable to the 0 is 1. Now these over here say -1 times 2 to the 0. This part is 1, 2 to the 0, but -1 times 1 is -1 total. Okay, and then over here, -1 times 4 to the 0. Well, 4 to the 0 is 1. And then -1 times 1 is -1. So make sure you understand that there are 2 steps. PEMDAS kind of takes over here on these 2, where these are just 1 step. It says any negative power, this is our second rule, can be evaluated by moving the base and the exponent to the opposite part of the fraction. So you cannot evaluate a negative exponent. If you put it into your calculator, it will give you a decimal. I don't want a decimal, I want a fraction. So in order to simplify, I have to change it. So because this has an unhappy exponent, I have to move it to the denominator. So it was over 1, so now I switch it. Put the 1 on top, put the 7 to the second on the bottom. So this is 1 over 7 times 7, which is 1 over 49. I do not want a decimal there. Same thing here. You've got an unhappy exponent. So you move it to the bottom part of the fraction. So that's 1 over 2 times 2 times 2 times 2 times 2. So that's 1 over 32. No decimals, please. And then a to the -6, I move it to the bottom. And you can't evaluate a to the 6 because you don't know what it is. So that's your answer. Okay, this one, you've got unhappy ones in the denominator. So kind of like a bunk bed. If they're unhappy in the bottom bunk, you would try the top bunk. So this would be c to the 8th power. You can't evaluate because you don't know what c is. 9 to the second would go up to the top. You can evaluate that. That's 9 times 9, which is just 81. And then 10 to the 7th is unhappy, so he goes to the top. Notice that the base doesn't change when I move it. Only the exponent changes sign. That's it. All the other numbers stay the same. So 10 to the 7 would be a 1 with 7 zeros. 1, 2, 3, 4, 5. Yep, that's right. And then put my commas in so we can read it. So that's 10 million. Very good. All right, so are we going to leave it alone or move it? And we know that by looking at the exponent. So as you look at the exponent, you should be able to say whether or not it is happy or sad. Happy means leave it alone. Sad means we're moving it. So this one right here is unhappy. So we would have to move it to the bottom part of the fraction because it has a negative exponent. And then we could evaluate 1 over 49. Hey, this one's perfectly happy where it's at. It has that positive exponent. So 8 to the 3rd power was 512, I think. I think I remember that from before. Okay, this has got a happy exponent. It doesn't matter that the base is negative. It has a happy exponent. So I just evaluate negative 4 times negative 4. That's a big negative sign. And it's 16. Unhappy, unhappy exponent. So I move it to the opposite part of the fraction. And down here, I've got some parts that are happy and some parts that are sad. We'll highlight the unhappy parts. So a to the 2nd is super unhappy. We're moving that, but we're leaving the 7 and the b where they are. So 7 and b are happy up top, and a to the 2nd moves to the bottom. And then over here, unhappiness would be the y. The other two are fine. Remember, a negative base is perfectly happy. Only move negative exponents, and that's my answer. Okay, so I'm only moving the piece that's unhappy or has a negative exponent. All right, so let's decide. We're going to make the exponent happy first every time, and then use a calculator for the power. No decimals. All right, so here we go. So we've got a happy exponent. I don't need to highlight it. I can just go ahead and write out what it means. So negative 4 times negative 4 is 16. This is also happy. Remember, there's the 4 is being squared, but the negative's not because there's no parenthesis. So this actually says negative 4 times 4, which is 16. Hey, that one's happy the way it is. So is that one. Okay, this one, unhappy. It's unhappy because it's got a negative exponent. So we move it to the bottom. 1 over 5 squared. That's 1 over 5 times 5, which is 1 over 25. No decimals. Okay, again, the next one's unhappy. He's unhappy because there's a negative exponent. So we move it to the opposite part of the fraction, which is 1 over 3 times 3, 1 over 9. All right, so there I have more. I mean, it's just the rule again and again and again, and you just have to figure out which ones to move and which ones not to move. So as I look at the first one, the 5 is perfectly fine where it is. The a to the 3rd is perfectly fine where it is. The b to the 2nd needs moved. He's unhappy. So 5a to the 3rd over b squared. Okay, as we look at the next one, we've got 2 unhappy ones that need to go to the bottom. The a is happy where it's at, so he stays. 2 squared goes to the bottom, and b to the 3rd. And then I can evaluate 2 squared. So that's 4b to the 3rd in the denominator. Okay, so here I've got an unhappy one in the denominator or in the bottom bunk, so I'm going to move him to the top. So x to the 5th, and y was happy where I was, and he stayed up top. Okay, so here I've got an unhappy one here. So a is going down to the bottom. Whoop, not a highlighter. C is staying on the bottom, and the negative 3, 6 stays where it is as well because there's no negative exponent. They have positive exponent of 1. But 3 over 6 simplifies to 1/2. So 3 goes into 3 once, and 3 goes into 6 twice. So my final answer is negative 1 over 2, and then a to the 4th and c to the 2nd stays the same. Okay, and on this last one, I've got n to the negative 3rd, which is unhappy. He's going up top. 5 and a were happy up there already, and that's my answer. Okay, press pause, and can you give these a try and see what you come up with, please? And then I'll do them too. Give these a try. All right, here we go. First one, I've got an unhappy C. So he goes to the bottom. 4 and B stay up top. Can't write with a highlighter. C to the third goes to the bottom. Here I have x to the 0. That's not unhappy. It just needs evaluated. X to the 0 is 1. So negative 12 times 1 is negative 12. Okay, again, I've got t to the 0. Well, that's 1. But that's unhappy. S to the negative 3 has got to go down to the bottom. So that's going to be 1 over s to the third. Okay, both of these are unhappy. This one and this one. So I'm going to move all of that. I'm going to switch places. So I'm going to move this whole thing. 2 to the 2 goes to the bottom. 9x is still down there. And y to the third is coming up top. The reason 9x is still down there is because it still has own exponents of 1. So I just need to evaluate 2 to the second, which is 4. So this is y to the third. 4 times 9 is 36, and x is still on the bottom. Okay, these need switched. They're unhappy. So 2 to the third goes to the bottom. He's happy. 3 to the fourth goes to the top. Let's see, 3 times 3 is 9 times another. That'd be 81 on the top over 8. Improper fraction is perfectly fine. Okay, so here I've got some unhappies. I've got an unhappy here and here. So let's move things around. So 5 and n are okay, and 10 and c to the 7 are okay. A is going up top, and m is going to the bottom. Okay, and then I notice that 5 and 10 share a factor of 5. So 5 goes into 5 once, and 5 goes into 10 twice. So 1 a to the fourth n over 2 c to the seventh m. This is my answer. And this 1 right here is optional because there is a coefficient of 1. I don't have to write it, but I can write it. It's not wrong. All right, on this one, I've got 2 unhappies. B is unhappy, C is unhappy. I'm going to switch their spots. A is staying on the top. So C to the second comes up top, and B to the fifth goes to the bottom. Okay, I have more here, but we've covered anything to the 0 is 1, even if it's a big, giant, fraction-y quantity horribleness. Okay, let's do this one. So my unhappy is here, but B to the 0 is 1. So this is negative 10 times 1 on the top, and a to the fourth goes to the bottom. So that's negative 10 over a to the fourth. Here we have some unhappy, so we're going to move them around. And we have z is 0, z to the 0, so that's just 1. So on the top, we've got 11 times 1, 3m. I'm moving x to the top and y to the bottom. So 11 times 1 is 11, x to the fifth, 3my. That's my answer. Here, this means that both of these get a negative 2. So if I scratch this and give it to both, they're both unhappy. So that would be 16 over 9. Okay, here, x to the negative 2 is unhappy. So I move it to the top. 3 stays. Here, both of these get the negative 3. They're super unhappy, so I move them. And then 5 to the third is 125, and 2 to the third is 8. So that's my answer. The volume of a block shown can be found by the formula V equals S cubed. Write the volume in simplest terms using an exponent, then evaluate the volume. Okay, so volume is S cubed, and S equals 2. So V equals 2 to the third, and then the volume is 8 inches cubed. So we're just doing 2 times 2 times 2. That's all we're doing. Okay, you have an assignment on Canvas that covers all this. Remember, there are no decimals accepted. Everything's a fraction. And you can't leave any negative exponents. You can have negative answers, but not negative exponents. So give those a try and see what you come up with, and we'll practice again next time I see you. Have a good day.